Um, Good evening, my YouTube viewers. It's Crystal here. I'm just here this evening because I want to do another code review. In my last video, I did a code review on sklearn's SelectPercentile, and in this video, what I'm doing is I'm doing a sklearn select percentile, whereas select k-best, what you did was you selected a number of columns and the algorithm selected the 10 best columns out of that group to make predictions on, whereas select percentile, what happens is you select a percentage of the data set for the function to make predictions on. So that's the difference, but these are both feature selection functions and you can use both of them. So in the last video I did select k-best, so in this video I'm doing select percentile. In this video I'm using Jason Brownlee's sonar data set that has a total of 60 columns of data, and it is a classification data set. So I have written this program in Google Colab, which is a free online Jupyter notebook hosted by Google. But the problem is it's a very good platform to use, but the problem is that it does not have an undo function. So you have to be careful not to accidentally overwrite or delete any valuable code. If you do overwrite or delete valuable code, then you can go into the save history and you can try to retrieve the code through the save history or the revision history. So that's one thing that you can do to try to retrieve the code, but there's no guarantee that that is going to happen. And the reason why is because one time I was working on a program in somebody else's computer, and I tried to save it and it didn't save it properly, and all the work that I did was lost. So that means I had to redo it. So that is one incident I can think of where my valuable code was overwritten, deleted, or lost. So that's something that you really do need to be careful with when you're working with Google Colab. So the first thing that we did after we created the program is we import our libraries. And so what we do is we import NumPy as NP, which is a numerical computation library. Then we import Pandas as PT, which is a data processing library. We import matplotlib.pyplot as PLT, which is a graphics library. And then we import Seedborn as SNS, which is a graphics library that also has statistical elements to it. So after we import the library, what we want to do is we load the data set, and we use Pandas read CSV function to actually load the data set. And so we're using Jason Brownlee's sonar data set. And so this particular data set has 208 rows by 61 columns. The last column is your target. We check information on the data set, and you can see all of the columns or features are floats except for the very last one, which is an object. So we check for null values. There are no null values in that data set, so that's good. So now what we want to do is we want to analyze the target. And so we check for the unique values in the target, and the unique values are R and M. So I don't know a lot about sonar, but R means something and M means something. And so R is slightly less than M, which is good. And then what we do is we create a heat map, and I think that's a very nice looking heat map. We use Seaborn to actually create the heat map, and you can see where the boxes are light colored, that means there's a high correlation, and where the boxes are dark colored, that means there's a low correlation. So we check the correlation so you can see for yourself the correlation of all of these 60 columns. And then after that, what we're going to do is we're going to define our X and our Y variables. Your Y variable is your target, and it's going to be the 60th column of data, and your X variable is your independent variables, and it's going to be all of the columns except for the 60th one. So in this particular instance, we're going to drop column number 60, and axis number 1 means it's columns. We check our shape, and so X is 208 rows by 60 columns, and Y is 208 rows. And now what we want to do is we want to normalize, we want to normalize X variable. And what happens when you normalize the X variable is you take all of the values and you convert them to a level of between 0 and 1. And the reason why is because the values have to be close together on closely related dimensions, and it's easier for the model to make predictions on closely related dimensions. It's more difficult for the models to make prediction if there's a big variance between the values, because they'll possibly be on different dimensions. And now what we're going to do is we're going to use sklearn's select percentile and try to, because it's a classification problem. In this particular instance, we're going to make select percentile equals 100, so that's 100%. Transform X, fit transform XY. We check our shape. It's 208 rows by 60 columns, which is what we had to begin with, which is what we want. We split our data set into training and validating sets, and we're going to use sklearn's train test split to do this. So x train x val, y train y val equals train test split, brackets x y, test size equals 0.1, random state equals 42, shuffle equals true. And then we check our shape. So our x train Y train is 187 rows, and our X val Y val is 21 rows. So we're going to select our model, and I selected extra trees classifier from sklearn because extra trees is a really good algorithm. And so with extra trees classifier, when we trained and fitted the data into the model, we had 100% accuracy. And then when we predicted on the validation set, we had 100% accuracy. So we checked our metrics, and you can see we created a confusion matrix with sklearn, and you can see that we had 13 zeros and 8 ones, and no false positives and no false negatives. So that's good. We prepared a classification report, which was very good. So 13 is M and 8 is R. So there's your classification report. And so that was that was 100% accuracy. But now what we're going to do is we're going to take select percentile and we're going to make it 50%. So we're going to change the percentile to 50. And when we change the percentile to 50, you have 208 rows by 30 columns. And then what we're going to do is we're going to use sklearn's train test split to split the data set into training and validation sets. And then we check our rows and columns. So X train, Y train, you have 187 rows, and X val, Y val, you have 21 rows. So we're going to use the same classifier that we used previously, and when we trained and fitted our data into the model, it had 100% accuracy. And then what we're going to do is we're going to make predictions on the validation set, and when you only have 90.47% accuracy, when you have 50% of the columns that you had previously. So that means that your accuracy has decreased by 10 points. And then we use sklearn to create a confusion matrix, and you can see that there are 11 zeros and 2 false negatives, and 8 ones and 0 false positives. And then after that, what we do is we create a classification report, and on this classification report, you can see the M is 13 and R is 8, and then your precision, you see that your precision, your recall, and your F1 score. So that's it. That's it for this particular code review. We've used the we've used SelectPercentile, and you can see that when we use SelectPercentile, when the columns were 100%, you had a higher accuracy than when the columns were 50%. So what you need to do is you need to experiment. That's the largest data set I have, but if you've got a really big data set of like maybe a couple of hundred columns, you can try this out, select percentile with that particular data set and see what you get. See if your accuracy decreases when you decrease the percentile, because it seems like the accuracy does decrease when you decrease the percentile. So I'm going to go ahead and close this video because I've covered select percentile, which is what I wanted to do. And I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you very much for watching this code review. I look forward to making more code reviews for you in the future.